Here's a great question that my good buddy, I've known him since the first day of sixth grade. He Here's a great question that my good buddy from the first day of sixth grade. He was tutoring somebody, and he had this one for me. So we have a 9 by 12, so 9 by 12 inch or units. Let's assume they're inches. 9 by 12 piece of paper. It's folded so that the two opposite corners coincide. What is the length of the crease? Now, what I'm going to recommend is that you pause it. Try this question. This is fascinating. And whenever you're trying to solve something that's a little bit weird, it always helps to draw a picture. So feel free to pause this at any time and give yourself some time to think. But I'm going to slowly and methodically work my way through this problem. This was kind of tough, if I'm being honest. So it's really kind of cool. This would be a great challenge for some Algebra 2 students for sure. Okay, so we have a 9 by 12 piece of paper. Now I actually like took a piece of paper and I folded it so that I could have the opposite corners coincide. Okay, so pretend that you're going to take this corner, top right, it's going to touch the bottom left. It's going to coincide. So it's going to fold. Now, it's going to look very, very interesting. It's going to look like so when you fold it. What's interesting, you get this right triangle. The corner, here's the corners mapping and touching the bottom corner. There's the fold. And then you have this congruent right triangle on the bottom there. That's the fold, so that those two corners coincide. So these are going to be the two key pictures that we're going to experience and we're going to play with. So again, feel free to pause and be like, oh, I'm going to give this a try, and then give it a try. Okay? So we, of course, will need some variables. Again, this is for Algebra 2 students. So at first, we can say, well, that fold, we're going to fold it. It's going to happen at X. This corner is going to come on down here. And if we call that an X, this portion is 12 minus X, because 12 minus X plus X makes the total length of 12. Every vertical line is 9, because again, we're dealing with a rectangle here, a rectangular piece of paper. Now, what's interesting is this is X, and that's also X. So this portion right here in blue is 12 minus 2X. That's from here in blue to here. I don't even know how well you can see this, so I'm going to make it be red. That's 12 minus 2X. So that's sort of taking the X off of each side. It was 12 total. We took away X on each side. We've got 12 minus 2X there. Okay. Again, this vertical is 9. So again, we have 12 minus 2X down low as well. And then if you want, you could call this Z. So we're ultimately going to make a couple of equations and then be able to set them equal to each other and kind of go from there. So let's see here. So if we did the Pythagorean theorem, we'd have z squared, that's the hypotenuse squared, equals 9 squared plus 12 minus 2x, quantity squared. So that's what I did at first. But then I started to notice some things. So that actually wasn't helpful. I may just edit that out or or something. But so this is x, this is 9. If you call this, let's call it m. We have a right triangle here where x squared plus 9 squared equals m squared. That's x squared plus 9 times 9 is 81. That equals m squared. If we square root both sides, we'll just ignore the negative root, because this is geometry, all distances are positive. So that hypotenuse is the square root of x squared plus 81. Okay, so that's kind of intriguing. So again, at first I tried this, but I don't actually think this was helpful. But so now let's kind of zoom in here. Okay, now there's oh no, I ended up using it. I don't know why I X'd it out. I did end up using it. Yes. Okay, now this is x. There's the right angle. There's the 9. We have these two congruent triangles from folding here. Now, this ... right here was the original 12 minus x. So that's intriguing. Now, we're actually just done. We get that m is 12 minus x. That's actually congruent. They're actually congruent to each other. So 12 minus x is equal to the square root of x squared plus 81. So all that hard work, I thought we were going to need this, and we really didn't need any of that work. So now we could square both sides. We have x squared plus 81. When we multiply out, when we square binomials, we can kind of multiply it out and distribute, depending on how old you are and how you were taught this. It really is just the distributive property. You might FOIL, if you will, first, inner, outer, last. Oh my gosh, I love when this happens. I love, zoom in on this, I love when there's an x squared on both sides, because I'm going to take away from one side. Whatever I do to one side, I have to do to the other, and boom, this is no longer a quadratic. That's great, because up here I was concerned that it might be kind of ugly. Down here, it's not so bad. I have 144, combine like terms, minus 24x equals 81. I'll take away 144. That's negative 24x equals, what is that? 63 with a negative sign. Divide both sides by negative 24. X is negative 63, negative 24ths. And let's just simplify our fractions. Let's divide top and bottom by 3. We'll go negative 3. So we have 8 down low, 21 up high. X is 21/8. Now the problem is effectively solved. I mean, certainly, if you go back to the question, what is the length of the crease? We will end up having to use this now. So it wasn't all for naught. It's just we had to kind of eventually get there. Z is the size of the crease right here. So now we can take our x, 21/8. We're going to plug that in. So z squared equals 9 squared plus 12 minus 2. X was 21/8. And that quantity is squared. Now, if you want, I'll just be a little fancy here. I'll just square root both sides so that I can just key in on z. I have 81 plus 12 minus 42/8 squared. This all lives underneath the square root. That's 81 plus 12 minus 42 and 8. Well, if I divide by 2, I have 21 fourths. If I, let's keep going with this. Oh my goodness. If I multiply this out, I'll have 12 squared minus 21 fourths times 12, and that'll happen again. That's the inner and the outer of FOIL, which is really just the good old-fashioned distributive property. And then I'll add the last term. It'll be a negative times a negative. It'll be 21 fourths squared. Negative times negative is a positive. Oh my goodness. Now, if we clean this up, we should get what z is. 81 plus 144 minus 21 times 12 over 4. Let's clean that up right away. A knowledge of fractions will just make your life better. Oh, so that's just 63. Chop, chop. Minus another 63, of course. And then we have 21 squared. I don't know if I know that off the top of my head on Memorial Day. 441, okay. 441 sixteenths. Oh my goodness. So this is what z is equal to. That's the length of the crease. So that's 225 minus 126 plus 441 sixteenths, which was the artist formerly known as 21 squared over 4 squared. Okay? Just keep on keeping on. So that is, oh my goodness. If it was 225 minus 125, it would be 100. So it's 99 plus 441 sixteenths. When we add or subtract fractions, we need a common denominator. So let's multiply top and bottom by 16 here. So it's 16 times 99 plus 441. And now they're all over 16. Okay. I mean, we're getting there. I've got my cool color palette going here. I'm going to apply the square root to the top and the bottom. Square root of 16 is in our denominator. And then we have 16 times 99 plus 441. Well, 100 times 16, that'd be 16 followed by 2 zeros. We have 16 less than that, so that's going to be 1584 plus 441. Oh my goodness. We're almost there. We're almost there. Oh my God, I'm breaking out in song over here. All right, so we have 1584, 441, that's a 5, 2, carry a 1, 0, carry a 1, 2025. 2025. Okay, well, the denominator's a 4. That's cool. The square root of 2025. What on earth would that be? The square root of 2025. Oh, that's 45. 45 times 45 is 2025. Our answer for z, the length of the crease, is 45 fourths. That would be 4 times 11 is 44, and there's a quarter remaining. So, are the units inches? I think it's implied that the units are inches, but the crease is 11 and a quarter units. Wow, what a tremendous question. Please feel free to ask me questions in comments. Feel free to like and subscribe. I do puzzles, I do math, I do computer science, and a partridge in a pear tree. Have a great day.